Hello, Sauce here. I want to talk about canceling, something that many people can do without understanding maybe completely why it can be done or how it's done or what's happening to justify the canceling. So I've written a fraction here. You can also call it a quotient. It has 3x in the numerator and a 3 in the denominator. And many of you, I'm sure, can see that the 3's can be canceled. But what exactly is happening to the 3's when they get canceled? We can cross them out to show our work that they have disappeared, or they're going to disappear after they've been canceled, leaving the x. But what happens to the 3's? They don't become 0. The 3's become 1. They were a common factor that got reduced to be 1. Sometimes we can show that the 3's have become 1 by putting a little number up there. And this, if we wanted to show our work thoroughly, this 3x divided by 3 turns into 1x divided by 1. But since multiplying by 1 doesn't change a thing, and dividing by 1 doesn't change a thing, we often ignore that we're multiplying and dividing by 1, and we leave the x. So canceling means something that we don't often think about because we just know how to do it. But understanding what we're doing when we cancel can help us do more complicated problems. So canceling means that common factors in a quotient are reduced to 1. Take a look at our example and notice that we've done this. We started with a quotient. We have the common factor 3. Remember that a factor is a piece of a multiplication problem. And they were reduced to 1, which then we could ignore, and what was left was the x. We have to be careful, and understanding what canceling is can save us from making a very common mistake when we see something like this. We have a quotient. This is 3 plus x divided by 3. But I'm going to write an oops here because I'm going to do something that shows a common mistake. This here, very often, somebody will mistakenly reduce it to x because they see that this 3 and this 3 ought to be able to be canceled. But it's not canceled that way. So this 3 plus x divided by 3 is not equal to x. What can we do with it? I'm going to draw it again, and I'm going to show you that this 3 plus x, those are not factors, they're terms. And when you have two terms here, each one of those terms is being divided by 3. I'm going to show the step. I'm going to show the first term 3 in the numerator and divide it by 3, and then add the second term x, which is also being divided by 3. If we take this intermediate step, then we can see that this 3 in the denominator will cancel the 3, but only that 3 in that term. The 3 over 3 becomes 1. But the second fraction x is still being divided by 3, and you can't simplify it further. So this is how you can correctly change this situation, but it won't simplify further than this. What's the difference between these two examples? Well, in the numerator here, we had the product of factors, and in the numerator here, we have the sum of terms. And you can only cancel when you have common factor in the quotient, not a common term. Let's talk about this a little further with some more examples. Here I'm going to draw a quotient, a fraction, 3 times 4 times x times y. divided by 3 times x times z. Now this is a quotient, and if it had common factors, then I can reduce them to 0. I can cancel them and simplify what I have. These are all factors because they're all being multiplied. And so if I find a common factor in both the numerator and the denominator, then I can reduce them to 1. I can reduce the 3's to 1, and I can reduce the x over x to 1. What's left? In the numerator, I can ignore the 3 and the x that became 1 and just show the 4 times the y that remains. And in the denominator, I have 1 times z, and again, I can ignore those 1's because it doesn't change the value of z, it doesn't change the denominator, and show what's left. So in this, I canceled a 3 and I canceled an x. Let's give one more example. I'm going to write a fraction 12x z divided by 3z. This is a quotient. The things in the numerator and denominator are being multiplied, so they're factors. I can cancel if I have a common factor, and I can see quite readily that the z is a common factor that can be canceled. And what I have left is 12x divided by 3. And what I see, I'm not finished unless I've reduced or canceled it as far as I can, but what I see is two numbers that are not equal. So are they common factors? They're not. 12 and 3 are not common factors. But I can take a step to factor the 12, which means show it as a product of two factors that when multiply equal 12. 3 times 4 is equal to 12, so 12 can be shown as 3 times 4. And when I do, I then create a common factor in the quotient that can be canceled. And after canceling the 3's, I have 4x remains. The denominator became 1 because the 3 was the only thing, and division by 1 can be ignored. So all that remains is what was in the numerator, 4 times x.